Hello and welcome to the webinar Smarter Tooling Starts Here, How 3D Printing is Changing the Game. My name is Nicola Giannelli. I am FDM Enablement Director at Stratasys. I joined Stratasys 10 years ago. I am an aerospace engineer, and before joining Stratasys, I was working at a major aerospace OEM in Europe as a structural engineer. A few things before we start. First, please use the Q&A section at any point during this webinar, as there will be a live Q&A with speakers at the end. And second, this webinar is being recorded and it will be available for reference on stratasys.com under resources. You have seen in the video as the introduction that Stratasys is the inventor of the FDM technology. So let's look now at what is our mission at Stratasys. So our focus as a company is on being the first choice for polymer 3D printing. We want to deliver the most innovative, highest quality additive manufacturing solutions for designers, engineers, and manufacturers of end-use parts. Manufacturing is the largest and fastest growing part of the 3D printing market, especially now as we reach an inflection point in the adoption of additive manufacturing for production. And polymers, due to their strength, lightweight, and versatility, represent the largest segment of this manufacturing market. Stratasys has long had an established high-quality ecosystem around polymers with our industry-leading FDM and PolyJet technologies. These two technologies continue to have the highest market share for industrial use. In addition to that, we are expanding our systems, materials, and software offering, leveraging our deep industry expertise, and we want to serve the entire product value chain. Let's look at the agenda of today's webinar. First, we will look at the current manufacturing landscape, and so at the challenges that the manufacturing company is facing during its operation. Second, we will look at the FDM solution. So one of Stratasys technologies, what are the characteristics of this technology and how these characteristics make this a good solution for the challenges that we will see in the first chapter. After that, I will have colleagues joining me in different sections to see different aspects of how Stratasys is providing solution to our customer. First, customer stories. So we will see how our customers implemented our technologies to solve their problems, and especially we will look at the materials that they use for success. Then we will have a look at the software solutions. So how Stratasys provides tools to its customers to solve their problems and to really make the best use of its technologies. Last, we will have colleagues from Stratasys Direct Manufacturing joining us to show how you can quickly and easily get started in your journey with additive manufacturing. So as we said in the agenda, first we will have a look at the current landscape and at the challenges that manufacturing companies are facing today. We have several challenges, of course. One of them is weight. So manufacturing tooling being usually made out of metal weigh too much, and having also big geometrical constraints, they are usually also not ergonomical. So it's difficult for the operator to move these manufacturing tools, and it can introduce delays and problems on the manufacturing chain. Second, current tool breaks and requires stiffness. The limited material selection is one of the limiting points for the current tooling capabilities. So of course, if you have a weak material, you will have a tool that easily break, and the same applies to the stiffness. Next 2 points are related to cost and time metrics. So tools are usually costly, and when they are removed from the job site, or they are lost, there's a big cost associated with their replacement. In addition to that, there's also a long lead time that usually is needed for production or for replacement of a tool. We see here in this slide, we typically have a lead time which is between 6 and 12 weeks, and that means that during this time we are without a critical job aid. So as promised, let's have a look at the FDM solution from Stratasys. It's diffuse deposition modeling, and as you have seen, Stratasys is the inventor long time ago of this specific technology. This is indeed a patented technology, and let's have a look first at the properties of the technology, and second, how it works. First of all, this technology is capable of building durable and accurate parts. This is used thanks to the material availability and flexibility for concept models, functional prototypes, manufacturing tools, and so jigs and fixtures, and then also end-use parts. Looking at materials, Stratasys provides the availability of standard, engineering grade, and high-performance thermoplastics. And thanks to the quality of its hardware, Stratasys FDM enables for professional industrial 3D printing. Now, looking at the animation in this slide, we see how this technology works. So it's a filament-based technology, so the material is available through spools of filament that are loaded into the machine. Then the thermoplastic filament is heated to a semi-liquid state and then extruded across a computer-controlled toolpath, and then it's building the parts layer upon layer. Why is FDM a great solution for manufacturing companies? Well, there are several aspects that makes FDM the best suited solution for tooling especially. I mentioned it in the previous slide. First key factor of FDM is materials availability, material flexibility. So what do these materials bring with themselves? One very important characteristic is the impact resistance. So for example, we have nylon 12 CF, which has a very high impact resistance. So that practically means that the tool won't break if it is subjected to any kind of impact. In addition to that, we have really high mechanical properties, once again with carbon-loaded materials. So in this example here, we have nylon 12 CF, but we will see later that Stratasys has also ABS and nylon 10 loaded with carbon. Well, these materials have really high mechanical properties, and that means that you can really stress the components that you produce with FDM. In addition to that, FDM is extremely easy to use on the factory floor. You can easily integrate FDM machines into your factory floor, and then we have seen many materials, for example, are available. It's extremely easy to switch from one material to the other one. It's also very quick to switch between materials, and so all these characteristics make FDM the easiest to use technology on the factory floor. It's also clean, so differently from powders or resin, you will not have material spill over around the factory floor or powder around the factory floor. Looking at the economics of FDM, its return on investment is typically between 9 and 18 months. So what does it mean? Thanks to the application enabled by the FDM, our customers are usually able to pay for their investment in only 9 to 18 months. And once again, to reinforce on the flexibility of this technology, really one printer, one system covers multiple applications. So you don't have to have a dedicated system for each application you want to produce, you want to work with, but you will have only one printer that can cover multiple applications. So we have seen how FDM works. We have seen why FDM is a good solution for manufacturing users. Let's now look at why Stratasys within all the FDM landscape is representing the best solution for customers. I identified four main reasons. First, more dependability. Stratasys is providing really high quality hardware. That means that your parts will be accurate, will be strong, They will be repeatable and reliable across different manufacturing cycles, and these are unique properties to Stratasys. Second, more application. As I mentioned, and as we will see many times during this webinar, Stratasys and FDM means material flexibility. Material flexibility means enabling more applications. So thanks to the possibility of using different materials, you will be able to apply a single system to multiple applications. Resources, more resources from Stratasys. As you have seen from the video, as I mentioned previously, we are the inventor of FDM. We are on the market since more than 30 years. And during this long experience, we developed a huge library of knowledge and documentation, which is available to our customer. In addition to that, we have a big partner network around all the territory, and our partners are as well capable of supporting you during your additive manufacturing journey. Effectiveness is the last but not the least important point. So since our systems are so high quality and the parts delivered has so high accuracy, strength, repeatability, and reliability, we are really able to compare our products with traditional manufacturing. We will, of course, not always replace traditional manufacturing, but we are there to work aside traditional manufacturing to provide new solutions that we will see reduce cost, reduce lead time, and provide more effectiveness to the components that you will use during your daily operations. And now let's look at some customer stories. Today with us, Derek Cagle, Manager, Material Business. Derek, can you introduce yourself and give us a bit of your background?
Yeah, thanks so much. Yeah, happy to be here today. As you mentioned, I'm the Material Business Manager covering all of Americas. Been with Stratasys a little over 9 years, working in various customer-facing roles. So super thrilled to dive into some customer stories today.
Thank you, Derek. So what is the first customer story?
So the first case study we have is from Invent. So Invent needed a material that could accommodate up to 40 load and unload cycles per day. It also had to exhibit some low sliding friction to minimize the force needed to insert and remove the manifold. One solution they explored was to do a machined metal part. However, this solution had several drawbacks. There's long lead time for fabrication. There's material waste associated with machining. There's constraints of different geometries, and the sliding friction still wouldn't be resolved. So the solution was they went to FDM printing. They looked at our Duran material, which they were able to produce an effective support tool in just under 22 hours. In contrast, they went to their internal machine shop, which estimated a 2 to 3 week lead time for machine components. This resulted in a 56% material cost savings and a lead time reduction of approximately 90%, which is ultimately your speed to revenue. Next, we'll go over to General Motors. So traditionally, tooling has been machined from aluminum and requires a really long lead time of over 10 weeks, which in a pre-production environment is a long time. Also, if tooling needs changes, doing it the traditional way can have significant delays in your production. In addition, the tool is also heavy, requiring lift assistance to position it on the car. This opens the potential for damaging the sheet metal from hard contact with the tool. So they evaluated what should they do with their tooling. They landed on FDM and ASA, which is a thermoplastic. It offers lighter materials, much shorter lead time, and gives them the ability to fast iterate when design changes are ultimately needed. ASA in general, one of our most common plastics, offered in a wide variety of different colors. So with their tooling, switching to ASA, they were able to produce some of these tools in 3 weeks, when traditionally it'd be 10 to 13 week time frame, a lead time savings of over 70%. In addition, it became more ergonomical. With the metal, it was 75 pounds for the metal tool. With 3D printing, it moved to 33 pounds, negating the need for lift assistance and improving the ergonomics. Total cost savings was reduced to 74%. Next, I'll highlight a commercial products manufacturer. So they had kind of three main challenges. High costs. So traditionally, the prototype required a $12,000 mold or machine from solid aluminum, which is both expensive options. They had slow turnaround time. These methods are time consuming, delaying development. And then they also had design limitations. There's constraints with draft angles, the cutter paths, which restricted overall design freedom. Their solution is they went to our ABS CF10 with a 10% chopped carbon fiber selected for its superior stiffness. It's over 50% stronger and 50% stiffer than our standard ABS. It provides a stronger, more rigid material option for applications across multiple use cases. Overall, the results they saw was the cost of the part was only $200 in material compared to $12,500, which represented a 98% cost savings. In addition, the part only took 12 hours to print compared to 1 to 3 weeks, which is almost a 95% time savings and ultimately speed to revenue using additive manufacturing. Now let's meet Graco, one of the world's leading suppliers of fluid management.
So this is a hand assembly tool that's used on our manufacturing assembly floor. We currently make these in ABS. Over time, these parts in ABS will wear out, where this really doesn't engage. This new material is going to make it much stronger, and it's going to last over 10 to 20 times longer so that we don't have to keep replacing parts.
Yeah, we have another great case study from our friends over at Graco. So their challenge was they were prototyping sheet metal brackets using CNC, which is both expensive and time consuming. Their solution was they landed on nylon CF10. It's a great chemical resistant material. It has soluble support that allows for design freedom in complex geometries, high performance strength and stiffness. It's 84% stronger than our ABS CF10, ultimately leading to some great cost savings. So overall, 80% cost savings, 90% time savings as well. Yeah, now I'll highlight another use case from Gossiger. Their challenge was during the machining process in their lathe, 2 halves of the finished hose clamp are cut off from the raw material bar. Without a way to capture these parts, the 2 halves would drop to the machine's floor and be carried out of the chip conveyor. A traditional solution involved the creation of an expensive and limiting parts catcher secured to the machine body. However, this would restrict its functionality and negate its intended purpose of increasing the machine efficiency. The solution, they turned to FDM and our nylon CF10 material and printed a catcher device that attached to the lower turret. They chose nylon CF10 due to the chemical resistance and wear resistance that it offers. Ultimately, the results afforded an agile solution that enabled the fast design and manufacture of a mounted catcher. The material itself provided the durability to withstand the lathe's cutting environment, which includes machining fluids. Next, let's dive into a quick video highlighting our nylon CF10 material.
This is a drill guide, a tool commonly used in locating and drilling accurate holes in complex shapes. FDM nylon CF10 chopped carbon fiber material is perfect for this application. It provides the stiffness needed along with accurate, precise results, all while being lightweight and easy to use. Reliable productivity wherever you are on the easy-to-use F123 CR series 3D printers with Stratasys FDM nylon CF10 material.
Thank you, Derek. Very interesting applications and great advantages achieved using Stratasys solution. Let's keep diving into Stratasys offering, and for that, I welcome Eric Gold, Sales Manager Software, on the stage. Eric, could you give a brief introduction of yourself?
Yeah, thank you. My team and I are responsible for not only helping companies to discover the value that our technology brings to them, but also to make sure that they use it successfully and they find value from it. You know, we're really focused on helping companies to create better parts, to help them to make them faster and less expensive and stronger, but also to help the workflow within their company to make sure that people can request parts, that they understand what's going on in their labs, and to provide them insight to help them make better decisions.
Thank you, Eric. So could you tell us a bit more about how Stratasys software can help manufacturing companies succeed with additive manufacturing?
Sure. Look, I love engineers. I've spent my entire career working with design engineers, providing them 3D CAD software to help them design better products. And during this time, I've found that manufacturing engineers and tool designers often don't get access to these powerful 3D CAD solutions, or simply don't have the training or knowledge to use it. And therefore, tool design becomes a bottleneck. Companies have to wait for their product designers to have time to design tooling, or they build rudimentary fixtures just to get the job done. This is why I'm so excited to introduce FixureMate, the solution we have been showing you as I've been talking. So FixureMate helps those with little to no 3D CAD experience to design 3D printed fixtures while reducing design time by 80%. And beyond that, fully integrates with our existing software solutions that help designers to make better 3D printed parts and to provide them and their entire company the ability to submit and cost 3D printed jobs. FixureMate will be fully integrated with our software tools and released in a few weeks. If you want to learn more in the meantime, just hit this QR code and we can reach out to you directly. And if you're ready to get started, I think that Nicolo and Brian are going to provide you a couple of options.
Thank you, Eric. We have two primary ways to get started. The first being our trusted network of local channel partners, and the second, Stratasys Direct. That's our contract manufacturing division. They are ready to take care of your most complex additive needs. Our local channel partners are ready to help you with the most challenging geometries with application selections, benchmark for testing, and even pre and post installation support. So our experts are in your communities ready to assist you. Now I will introduce Brian Workentine. Brian is a senior manufacturing engineer at Stratasys Direct. Brian, please introduce yourself and give a brief overview of your role here at Stratasys Direct.
Okay, thank you, Nicolo. Hi, my name is Brian Workington. I'm a senior manufacturing engineer at Stratasys Direct. I've been with Stratasys Direct now for 6 years and have over 20 years experience in the aerospace manufacturing industry. At Stratasys Direct, I support our quoting team in reviewing models and drawings for producibility. I also support our manufacturing operations team by leading process improvement activities and providing design and manufacturing shop floor support.
Thank you, Brian. So can you tell me about the benefits of Stratasys Direct and how you operate as our contract manufacturing division?
Stratasys Direct is a subsidiary of Stratasys that provides parts direct to the customer. We offer a full range of printers, materials, and technologies. We have 3 facilities here in the United States and offer engineering support and a full service post-processing. All Stratasys Direct facilities are ISO 9001 and AS 9100 and are ITAR certified, and one of the facilities is currently ISO 1345 for your medical needs. We service a wide range of industries from industrial manufacturing to medical. We offer several additive technologies, anywhere from FDM and filament, SLA and P3 and photopolymer, polyjet and jetting, SAF, MJF, and SLS and powder-based. Stratasys Direct is your end-to-end solution for turnkey additive manufacturing with attractive pricing and quick turnaround times. To get started with Stratasys Direct, click the Rapid Quotes link below.
Okay, I can see questions starting to come through from our audience, but before we dive in, I would like to take a moment to reiterate the value of adding Stratasys to your manufacturing processes. So we have seen one of our 5 technologies, so we have 4 additional technologies best in class to offer you. In addition to that, we provide a full material ecosystem and a full software platform, which is ready to provide you Industry 5.0 solutions. Alongside our technology, material, and software solution, we have a data-driven customer success team. And of course, we mentioned it, we have a full library of use cases that can show and highlight how to successfully implement Stratasys solution within your business. And with that, I will invite my co-host back on stage and we will answer your questions. So we have the first question. Actually, it's two questions which are similar. So I will take the first part for FDM, and Brian, please take the second one from SDM. What are the typical dimensions of the tooling we are referring to? Okay, when talking about dimension, on purpose, we didn't talk too much about the printers themselves. In this webinar, we wanted to provide more an idea of the solution. Printers themselves have a pretty wide range. So when we talk about what we call the office-friendly printer, so the F123 series from Stratasys, that series of printers ranges from a 10 by 10 by 10 inches build envelope to a 14 by 10 by 14 inches envelope. But we have also manufacturing grade printers, which are from the Fortus series, so the Fortus 450, the F900, and the F3300. Let's take the 900 as the biggest build envelope, so it's 36 by 24 by 36 inches. So that's how we can define the maximum size of the tooling that we can print in each of the systems.
Okay, Nicolo, you mentioned there was another question regarding print size and Stratasys Direct. We have a question. My fixture is very large. What is the largest fixture Stratasys can print? So Stratasys Direct has quite a few printers in inventory. Our largest printer is the F900, and Nicolo mentioned 36 by 24 by 36 is the print volume. If the fixture is oriented diagonally, that equates to roughly a 40-inch length part. Stratasys Direct also has the ability to build parts in sections and assemble them after printing to allow for an unlimited part size.
Thanks, Brian. Yeah, I see there's one in the chat for me as well. So the question was, what sets Stratasys materials apart from the competition? Overall, I'd say we do hundreds of hours of testing. These machines are made to use on our machine, which leads to kind of the consistent results, the reliability and repeatability on each print using our materials.
I think I'll take the next one. If that's okay with everybody. Question is fixture mate specific to Stratasys machines? You know, what if I need to create fixtures for other types of equipment? The answer is we would love it if you exclusively used our equipment and our materials, but reality is we understand that that's not always going to be the case. You may have overflow needs, whatever it is. So yeah, you can export these fixtures as STLs, as 3MFs, even as step files if you need to edit them further. And so you can print them pretty much wherever you need to print them. And we're trying to provide, we're trying to prevent you, we're trying to provide you that type of flexibility.
Okay, and I can grab the next one. So question, my fixture is an assembly with both additive and off-the-shelf parts. Can Stratasys build the entire assembly? So Stratasys Direct is a turnkey manufacturer. We offer many different post-processing processes. We do anything from machining to paint to assembly as well. So certainly, if you have a fixture and there's some clamps, hold-down clamps, and bushings to get added, we can certainly do that for you.
Here, I'll get this one. Can I get a software demo? The answer is yes. There was a QR code that I presented earlier, so you can absolutely do that. Hopefully you can go back and click on that. If not, you can contact me directly at my Stratasys email address, and I'd be happy to set something up for you.
I can take the next one. So that's a tricky one, actually. What's the typical print speed of this system? Well, the answer is that it depends. So typically additive is very geometry dependent. So we don't have a unique data to define the printer speed. but it can open a little bit the conversation to what the real advantage of additive is, which is designed for additive manufacturing. And specifically for FDM, I can bring a couple of examples of how you can improve the speed and the efficiency of the production way you are using. So for example, FDM, you can design the part to be self-supporting. So there is an angle over which you don't need support material. So if you design the part features such as they are above this angle, then you will not need to print support, and you will not need the time and the cost of printing that support. In addition to that, FDM can have an infill which is different from being solid or completely full. We talk about different infill patterns, and each of them has a different structural property or mechanical resistance it brings with itself. So by coupling these two things, you can adapt the geometry of your part to your needs. You can really optimize the printing time and speed in order to be the lowest to accommodate your desired characteristics. So really, it depends. So we have data on the extrusion speed, but it really depends on the part design.
It looks like, yeah, I can handle the next one. The question was, where can I find more information on Stratasys materials and their data? So our website's a great resource. For each material, we have the data sheets, and we also include safety data sheets as well, if needed, and that can be all found on the Stratasys website.
Next one is very easy. I wanted to learn more about the F123 series Stratasys printer. Can I contact Stratasys directly? Yes, the answer is yes. Of course, we're here to support, and you should have a link here on the screen that you can click on, and for everybody to directly contact Stratasys. But we can see your name, so who made the question, and we will contact you specifically directly.
Yeah, but it looks like the last one I can take asked about time savings for fixture mate versus traditional fixture design. And this is really exciting. We're being told that fixtures that are taking 2 to 3 hours to design in traditional 3D CAD processes are taking 20 to 30 minutes using fixture mate. So that's an incredible time savings. And it's really based on this kind of automation process and kind of a templated process of going through and designing rather than having to go through complex 3D CAD rules and processes. So exciting time savings. We're so excited to bring this to you. And again, if you want to hear more, please just reach out and let us know.
All right, so it looks like this was the last question. So once again, thanks to all the presenter and of course to all the attendees for being here today. Wish you a nice rest of the day.